Activity number 3, arrangements and combinations, permutations and combinations, really. Two objects must be chosen among three distinct objects, A, B, and C. Describe the different choices possible when order is taken into account. In this case, order is important. We're talking about permutations. Permutation where repetitions are allowed. So the difference between picking A, B, and BA. We could do AA, AB, AC. We could do BA, BB, BC, CA, CB, CC. For the first, we have three choices. For the second, we have three choices. So it's going to be 3 times 3, 9 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9 choices. So 3 for the first choice times 3 for the second choice. 3 to the power of 2. Or n to the power of r. When order is taken into account and repetitions are not allowed, it's exactly the same thing we did up here, just we can't have AA, AB, or CC. We get AB, AC, BA, BC, CA, and CB. We have three choices for the first choice times 2 second choices for the second choice, which gives us our 6 choices. We can think of it as 3 factorial. And really, it's 3 factorial divided by n factorial divided by n minus r factorial. Our way of saying like 3 times 2, it was, let's say we were taking 2 objects out of 5 objects. So we have 5 for the first choice, 4 for the second choice. So 5 times 4. How do we write 5 times 4? N factorial. This is like 5 factorial divided by 3 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. But we only want the 5 times 4. So we want to get rid of the 3 times 2 times 1. So we divide by the 3 times 2 times 1, which is n factorial, n minus r factorial. For C, order is not taken into account and repetitions are allowed. So this is a combination with repetition. This is the hairy one with that awful formula. Let's first have a look at what we're talking about. Repetitions are allowed, so AA is good. AB, it's just if we have AB, you can't have BA. If you have AC, you can't have CA. If you have BC, you can't have CB. We end up with everything we had up here, except I've removed where the order has been switched around. We have AA, AB, AC, BB, BC, CC. So there's 6 different choices. You remember that awful formula? Let's see if it works for this. If our n is 3 and our r is 2, that gives us 3 plus 2, take away 1. 5 take away 1 is 4, 4 factorial, which is 24. Divided by n minus 1, so that's 3 take away 1 is 2, 2 factorial, and also divided by r factorial, which is 2 factorial. We have 24 divided by 2 times 2. 2 times 2 is 4. 24 divided by 4 is 6. We have 6. There's 6 choices. D, order is not taken into account and repetitions are not allowed. This is the one, looks kind of like this, but then we're saying because the order matters, the number of ways of writing them needs to be reduced to 1, right? So if we're taking 2, if we have 2 of them, what we want to do is we want to reduce that, we have 2 choices. The only way, the number of ways of writing 2 choices is just, like if you have AB, that could also be BA, right? So AB and BA, that's 2 different outcomes, needs to be just written as AB, okay? So we're going to divide by 2 factorial. So exactly this, but also dividing by r factorial. So we end up getting, it's exactly what we had up here, just without the duplications. So we have AB, AC, and BC. BB isn't allowed, CC is not allowed, and AA is not allowed. It's exactly the same as up here, but just divided by, we have 3 factorial divided by 2 factorial, which is just 3 outcomes, 3 choices. The first instance, permutation with replacement. The second one is a permutation without replacement. The third one is a combination with replacement, really hairy one. And the last one is combinations without replacement. And that's it for activity number 3. Have a good day.